Hi everyone, so today let's revise Lean System and Innovation, the third chapter, which is one of the most important chapters for this attempt, for November 22 attempt. So I'm not going to show you the book. Please open to your study material so that you'll be able to go through the content in your material and listen to the lecture. It's kind of troublesome to hold the phone like this and to shoot, so that's why I'm doing this technique. Hope you understand. So let's start with Lean System. The definition of lean system. There are three things that we have to remember in case of lean system definition. What is it? It is waste minimization without sacrificing the productivity. You're not sacrificing any productivity, but you're reducing the waste. Waste minimization without sacrificing the productivity, optimizing the workflow. It optimizes. What does it do? It optimizes the workflow. So there are three things. One is waste minimization without sacrificing the productivity, optimization of workflow. These three things. That is the definition of lean system. Second thing, there are 7 ways you can remember, just like maybe like 3-4 we can remember. What is it? It reduces the inventory, then transportation cost. Inventory, to bring the inventory we need transportation, so it reduces the transportation also. Then it helps to reduce the over processing and over production. It helps to reduce what? Over processing and over production. So these 4 things we can remember. One is inventory. To bring inventory, we need transportation. Transportation also it reduces. Then over processing and over production. 4 things. Okay. Next, there are 7 ways in the lean system. The first one is just in time. Okay. So there are 7 ways which we already studied now. And to reduce this, we have some techniques. First technique is just in time. What is it? Just in time. Last attempt we had just in time questions. So this attempt may or may not come, so let's just go through. So what is just-in-time approach? It is a collection of ideas that streamline a company's production process activities to such an extent that wastage of all kinds like time, material, labor, it's systematically driven out of the process. It is systematically driven out of the process. So just-in-time has decisive positive impact on product costs. Okay. In just-in-time, we have just-in-time production, just-in-time purchasing. Okay, what is just-in-time? It's a collection of ideas. Just-in-time is a collection of ideas that streamline a company's production process activities to such an extent. It will streamline the company's production activities to such an extent where wastage of all kinds are driven out of the process. Okay, next. It is streamlined in such a way where wastage of all kinds are driven out of the process system. Next. In just-in-time, we have 2 things. One is just-in-time production and just-in-time purchasing. Okay. Next, now we are reducing the raw material in case of just-in-time because we are not having any stock of raw material. We are just bringing as and when required. So process that vastly reduces the amount of raw material inventory and improves the quality of received parts. So how do we improve the quality of the received parts? So any which ways we are reducing the raw materials, but when we get the raw materials, it should be of top-notch quality. How do we ensure that? First thing, so it should be brought on the exact time and on the exact date. It should be brought on the exact time and the exact date. If tomorrow I'm producing this, on the previous day I have to get the raw materials, exact time and exact date. Then straight to the production floor. We'll directly take the raw materials to the production floor. Then, so to ensure the quality, the engineering staff should visit what? Supplier sites. To ensure the quality, the engineering staff should visit the supplier sites and examine their processes. Like engineering staff should visit the supplier site and examine the process whether all these things are properly done or not. Then EDI, there's something called EDI. So how do we know, there is a requirement for raw material? Either you can have a simplistic system like, fact system wherein you enter the number of items that you require for your tomorrow's production. Imagine 10,000 units. So that will be directly sent to them and they will send us 10,000 units. But when it comes to EDI, what is EDI? Electronic Data Interchange System. Electronic Data Interchange System. We can also use this, which is kind of advanced system wherein it'll automatically feed in the system. It automatically feeds in the requirement that the requirement of the raw materials, and it will be directly sent to your supplier. So you can use EDI or you can use fax, the basic fax system. So what is the first thing that we did to ensure the overview of the GIT system, just-in-time system? First thing is it should come on the exact date and time. Second thing, it will directly go to the production floor. Third thing, the engineering staff should visit the supplier's location to ensure the quality. Then fourth thing, how do you raise the order, either through fax system, which is simplistic, but you can also use EDI, which is electronic data interchange system. Then small deliveries, drivers then bring the small deliveries, so you're not having the entire stock for the entire month, the raw material stock. You're doing only just in time, like tomorrow whatever is my production, based on that I'm ordering. So they bring in what? Small deliveries, not big deliveries. Okay, this is something to reduce the raw materials. How do you reduce the work in process? Process in which the company reduces the amount of work in process while also shrinking the number of products that can be produced before defects are identified and fixed, thereby reducing the scrap costs. How do we do that? So working process, obviously when you reduce the raw materials, the working process will get reduced. It reduces the amount of work in process while also shrinking the number of products that can be produced before defects are identified and fixed. Okay. Next, we have reduced setup time. How do we reduce setup time, shorten the setup time? For machinery, in most of the factories, equipment is changed over to new configurations as rarely as possible. Setup time means what? This machine, like machine A, machine B, machine C, set this up in a proper manner. The flow should be set, correct? So how do we shorten this setup time? So setup takes a long time. Obviously, setups takes a long time. Company management authorizes long production runs, which spreads the cost of setup over far more units, thereby reducing the setup cost on a per unit basis. However, with this approach, too many products are frequently made at one time. So product obsolescence, inventory carrying costs, and many defective products. What happens if you have too many, like setup is done and there are too many products that have been produced from that particular setup? So what happens if you produce too many products? There's an obsolescence of the product. It goes out of, it becomes outdated, obsolescence. Then inventory carrying costs. We have to carry that particular inventory. Then many defective products are produced. But under GIT system, a different approach to the setup issue is followed, which focuses on making a videotape of a typical setup. You make a videotape of a typical setup, then how is it flowing and everything. Instead of reducing the length of the equipment setups and thereby eliminating the need for long production runs to reduce per unit costs. A team of industrial engineers and machine users examines this tape. Once you make a video of the setup, how the products are flowing from one machine to another machine, the engineers will see the tape and spotting and gradually eliminating the steps that contribute to a lengthy setup. So they gradually eliminate the step which contribute to a lengthy setup. It is not unusual after a number of iterations to achieve setup times of minutes or seconds when the previous setup times were well into hours. So gradually they will reduce based on the videotape that is made. Okay. Then difference between operating speeds. It is not sufficient to reduce machine setup times because there are still problems with machines not being coordinated properly. Okay, this is like too much of information. Then we'll go to Kanban card directly. What is Kanban card? So I already finished 8 minutes. Let's just quickly do this. So what is Kanban card? Kanban card is the card which enters the number of items that you need for a particular production, and it also records. Okay, let me just read. Kanban card, which is a notification card. It's a notification card that a downstream machine sends to each machine that feeds it parts. That a downstream machine sends to the upstream machine which feeds to its parts. Like upstream machine produces some products and it will send it to the downstream machine, and downstream machine, whenever there is a requirement for such products, it will send it to the upstream machine. In the Kanban card is like the notification card for that upstream machine. Then feeds its part, authorizing. It's a pull system. Whenever required, it sends the information. That's all. Then there is this concept called group machine into working cells. So group machines into working cells. We also have the cellular production something. One more topic which is related to this. cellular manufacturing it is called. So working cells, like divide them into working cells. Okay, then group machines into working cells, that is also can be done to make it effective, to make GIT system effective. Then what else? Grouping machines into working cells. Small cluster of machines run by single operator. Small cluster of machines is run by the single operator. What are the benefits of this? No working process built up, low maintenance, quality increase, easier to reconfigure, because one person is maintaining this entire thing. So what are the benefits of this? No working process built up. Working process is not there, because as and when when there is a notification, as and when we require it, we produce it. Low maintenance maintenance will be low. Quality increase because one person is taking care, because he is responsible if the quality goes down. So quality will definitely increase because he is supervising it. Then easier to reconfigure. It is easier to reconfigure. Reconfigure means to reset up. So this is about Kanban card and grouping machines into working cells. So this is for reducing the defective production of upstream machine. So downstream machine needs some products, and upstream machines directly produces the product, and if you don't take care of what it is producing, there can be defects in this. So we use Kanban card, one, to notify number of products, and we use grouping of machines into working cells, so that one supervisor is taking care of the entire process. That's all. So what is benefits due to GIT? What are the benefits? One is inventory handling cost comes down. Less inventory you're having, that's why inventory handling cost comes down. Insurance cost comes down. You usually take insurance for the products that are produced, so insurance cost comes down, warehouse cost comes down, and earning on the reduced cost, earnings will increase. These are the benefits of GIT. What? 3 reduction. One is inventory handling cost, insurance cost, warehouse cost. These 3 are reduced, and earnings are increased. Then expenses due to GIT. What are the expenses? Procurement cost, because the number of procurements that you make is more, correct? So procurement cost will increase. Increase in loss of contribution due to stock out. Sometimes what happens, there is you don't really expect that kind of demand. There is this irregular demand that happens. So so there is this loss of contribution. You don't have the products. You imagine, you thought the demand is for 10,000, so you maintain that stock for 10,000 products, but you see there are 12,000 products got demand. So there is stock out. So the loss due to stock out, and overtime cost. Okay, the next one is, what is the main features, the 5 main features that GIT production aims for? What is those? First one, material labor. You remember, material handling cost will come down, and labor idle time will come down. Material handling cost, labor idle time will come down. The third one is, GIT creates urgency for eliminating defects as quickly as possible. So the defects are eliminated as quickly as possible. Fourth one is, company can respond to customer demand faster. So defects are reduced faster, and company can respond to customer demand faster. Then the fifth one is, carefully selected supplier capable of delivering high quality materials. So you're selecting the supplier because you are relying on him completely, because the entire whatever he is supplying directly going to the production floor. So you are relying on the supplier. So you make sure that you carefully select the supplier, so that he gives you with the high quality products. Then what are the essential prerequisites? What are the essential prerequisites of a GIT system? Prerequisites. One is low variety of goods. If the variety is more, then you cannot apply GIT system. Low variety of goods. Then vendor reliability. How do you have vendor reliability? By having a good communication. So first one is low variety, vendor reliability by having a good communication. Third one is good communication. Fourth one is demand stability. You should have a demand. So I told you, stock out happens if you don't expect a demand. So that's why if there is an irregular demand, so there should be demand stability. Then there is something called TQM, total quality management. Then defect free materials. Prerequisites. These are the prerequisites for GIT system. For implementing the GIT system. Defect-free materials. You cannot have defected products, defected raw materials. So defect-free materials. Then preventive maintenance. So it cannot be, it should be prevented and not controlled. It should be preventive maintenance. So what are the essentials? First one is low variety of products, then low variety of products, vendor reliability, good communication, TQM, then demand stability, defect free materials, and preventive maintenance. Okay, there is impact on GIT system on three things. One is product prices, waste costs, and overhead costs. GIT system will impact on these three things. One is product price. Whether increase product price or decrease product price depends on how you implement the system. Product prices, waste costs, and overhead costs. Okay, there's something called back flushing in GIT system. What is back flushing is, let's go to the summary of at the last page for back flushing, because it's very nice there. Where is it? It is in page number 3.43. So what is this back flushing? Back flushing requires no data entry. It doesn't require no data entry of any kind until the finished product is completed. At that time, the total amount of finished is entered into the computer system, which multiplies by all the components listed in the bill of material. Okay, till you finish a particular production of a particular product, you are not entering any of the costs. So back flushing requires no data entry. It requires no data entry of any kind until the finished product is completed. Until the finished product is completed. At that time, when it is finished, at that time what you do, the total amount of finished product is entered into the computer system. The total amount, the total cost is entered into the system, and number of products that you have produced is multiplied into that with that. So this yields a lengthy list of components. This yields what? Lengthy list of components that should have been used in the production process and which are subtracted from the beginning inventory. So you deduct the opening inventory so that you get the actual production for this particular time, the duration. Then problems with back flushing. What are the problems? Incorrect production reporting, incorrect scrap reporting, incorrect production reporting, incorrect scrap reporting, impossible for lot tracing, impossible for lot. Sometimes it becomes impossible for lot tracing if you are not put the lot numbers properly. Impossible for lot tracing, inaccurate inventory record, inaccurate inventory record. Four problems of back flushing. One is incorrect production reporting, incorrect scrap reporting, production reporting, scrap reporting, then impossible lot tracing, inaccurate inventory records, Then this is about back flushing. And this is one illustration we have to solve, this KP limited illustration. Please solve it, it's very easy. What you have to see is what is the opening inventory, what is the production that has happened, and how much is the demand, and how much is the closing inventory. You take the average inventory and multiply with the holding cost. So that is what it comes in the inventory holding cost. And in case of relevant overtime cost for this labor, what we do, how much is the demand and how much is the production, what is the normal availability, because there is this 95% efficiency. So take the normal availability, what is the shortage, actual overtime hours, then overtime payment. That's all. So these things, so overtime payment is the expense, and whatever we have saved in case of inventory holding cost, so that one we have to take, and we have to deduct this overtime payment, and whatever is the saving we have to take. That's all. This is what is GIT system. That's all.